Hi guys, it's Miss Katz, and today I'm going to take a few minutes to work out the study guide for Unit 2. I'm going to do it in two parts. So this first part will be the front side of your study guide, and we're going to get started right away with question number 1. It asks us what 18 is 25% of what number? And we have been talking a lot about how we're looking at a part-to-whole relationship equaling percent out of 100, because a percentage is a part of 100, always is a part of 100. And so this is the general proportion that we use when we are solving percent problems. And remember that usually, not always, but is paired with part and of is paired with whole, especially in these simplistic problems. So if you're looking at it that way, 18 is 25%. That means it's the same as 25%. So what I've been recommending is we set up a structure just like this, because in every problem we're talking about two ratios, and one of which is the percent, and the percent is always out of 100. All right, now since the percent is always out of 100, that must mean the 25 goes above the 100. And then we got to figure out where that 18 goes. Well, 18 represents the 25%, which is part. So 18 is the part of some whole we don't know. Now, we talked about two different ways to solve this problem. I'm going to do it on this one so you can see. The first thing I would do before I do any solving is let's simplify this fraction so that we've got smaller numbers that we're working with. So if we divide by 25 here, and you may have not have seen the 25, you might have seen a 5, but simplify and simplify until you cannot simplify anymore, you're going to get 1/4. So I'm going to rewrite this over here so that we can kind of see it. Okay, starting with the ratio table method, we recognize that 1 times 18 got me 18. So whatever I do on the top, I need to do on the bottom. So 4 times 18, and if I don't know that, I'm going to take it over here, is 72. So 72. So the answer here is going to be 72. Okay, and we would write that as 18 is 25% of 72. Now, if you didn't remember to do the ratio table method, or you weren't sure how to do that, we also taught you how to use the butterfly method, where we multiply the two numbers that we know across from each other, and we divide by the third. Well, in this case, it's 18 times 4, which we've done. That's 72. And we divide by 1. Well, 72 divided by 1 is still 72. So either method will get me that solution. Okay? Let's take a look now at question number 2. Let me zoom in just a little bit so you can see these ratios a little bit better. In question number 2, it asks you to write the letter of the pair that do not, this is a big one, do not form a proportion. We're looking for the ones that don't work. There's a couple of different methods that we talked about to determine whether or not a set of ratios was in proportion, one of which was cross-multiplying. So if we multiply here, we get what? 12. And here, we get 18. Since those numbers are not equal, this is not a proportion, and the answer is going to be A. But let's go through some of the other methods that we use to determine, to determine whether or not something is a proportion. So if you look at choice B, one of the methods that we said was to simplify both of them. So if we simplify, this is already in simplified form. The only factor that 7 and 50 share is 1. But this can be divided by 2. And this can be divided by 2. And when I do that, I'm going to get 7/50ths on one side and 7/50ths on the other. So this is a proportion. Remember, we're looking for the one that is not. Okay, we also used the ratio table method. If I can find some way to turn one fraction into the other, then we can do that. So 3 times 12 here gives me 36, and 4 times that same 12 gives me 48. So that is in proportion. And for C, I'm going to go back to the simplify method. We're going to simplify this by a factor of 2. So I'm going to get 2/4. Actually, we're going to simplify it again because I wasn't paying attention. So really, this is going to become 1/2. And here, if you divide by 13, then you're going to get 1/2. Since they are equal, this is a proportion. So the only one that is not a proportion is A. Okay. Let's take a look at question number 3. Again, we're dealing with percentages. In this case, we're going to set up our structure. This is always out of 100. So let's fill in what we know then. We know that 60 is the percent, and the percent always goes over the 100 because a percentage is always out of 100. Okay, and in that case, we need to figure out where this 300 goes. Well, we're looking for the part that is 60%. So this is the piece I'm looking for of the total 300. In this case, I'm going to use the ratio table method because I know that 100 times 3 is 300. And 60 times 3 is 180. So the answer is 180. And to write that in a sentence, it would be 180 is 60% of 300. Okay, in question number 4, we've got to figure out what proportion we need to solve this problem. So Skylar sent 72 texts in 6 days. At this rate, how many texts will she send in 14 days? Okay, so let's take a look at this problem and let's break it down. What are the two things we're comparing? We're comparing texts to days. Okay, now in class we've been using little abbreviations to sort of remind us that all the texts will go on the top and all the days will go on the bottom. So let's start with what we know. We know that she sent 72 texts in 6 days. And then they gave us the 14 days. Well, the days are on the bottom, so the 14 goes here. And we're looking for how many texts she was able to send in that time. Now, the way that it's set up at the moment, I'm going to have trouble figuring out the relationship between 6 and 14, but I can simplify here. 72 and 6 share a factor of 6. So 6 goes into here 12 times, and 6 goes into here once. All right, and now we can see that 1 times 14 will get me 14. So 12 times 14 should tell me how many texts she sends. And let's do that. That's 168 texts. So Skylar sent or sends 168 texts in 14 days. Now let's think about this for a second. Notice that the number of texts she sends is much greater than the number of days that she actually sends them. Our answer here is 168, which is significantly bigger than 14. And 14 is bigger than 6, so we should definitely be sending more texts. In fact, 14 is a little bit more than double. So if we were to double this, we're looking in the 140-something range. So we should see that this does make sense based on the information that we were given. All right, this next one I'm going to rewrite because it looks like I wrote over it a little bit, but it was asking what value of x will make this a proportion. Okay, a couple of different ways that we can solve this, but again, every time I go to solve these problems, I'm going to simplify these fractions so that the numbers I'm working with are their smallest possible value. Here I can divide by 6, so I'm going to rewrite this. This becomes 2 over 1 equals x over 8. How did I get from 1 to 8? I multiplied by 8. Whatever I do on the bottom, I do on the top, so x needs to equal 16. All right, Pascal the lizard is 4 feet long. Louis the lizard is 60 inches long. We want to know how much longer Louis is than Pascal. All right, well, Pascal is 4 feet long, and if 1 foot, so he's 4 feet long, but we need to find out in inches because we're trying to compare inches to inches. So we don't know his inches yet. We're going to figure that out. But it does tell me that 1 foot equals 12 inches. So how did I get from 1 to 4? Times 4 times 4. That means that Pascal is 48 inches long. So what's the difference between 60 and 48? So it is, how much longer is Louis than Pascal? 12 inches longer. And really it should be that Louis is 12 inches longer than Pascal. Okay. Question number 7. The ratio of cats to dogs at a pound is 3 to 11. And if there are 42 cats, how many dogs are there? Well, let's take a look. So the ratio of cats to dogs, that's the order we're going to put them in. And since it's listed cats to dogs, That's cats to dogs. So that's 3 to 11. And we know that there are 42 cats, so that's going to go on the cat side, and we want to find out how many dogs that equates to. Okay? Well, we want to try to use that ratio table method if at all possible here. So we don't know what that number is between these two. And I apologize, I should have raised that earlier. But we can find it out by taking 42 and divide it by 3. 3 goes into 12 4 times. I've got no remainder, so it looks like 3 goes into 42 14 times, which means 3 times 14 is how I got 42. Whatever I do on the top, I'm going to do on the bottom. So let's do 14 times 11. And you can do it in either order because the commutative property of multiplication says, doesn't matter what order I multiply in. I like this method because the multiplication is going to be the easiest I can make it. Don't forget to put your 0 placeholder when you go to the next row. So it's 154. There are 154 dogs. All right, in a Chinese food restaurant, 80% of the guests are eating an egg roll. If 40 people are eating an egg roll, we want to know how many total people there were in the restaurant. So let's set up, because this is a percent problem, let's set up our generic percent problem. Okay, now we know that the 80 is the percentage, and the percent is always out of 100. For some reason, we had lots of trouble with that in class. But 80% means 80 out of 100. That's the definition of a percent. It's a part of 100. All right, now it says 80% is these are the people eating the egg rolls, and this represents the total people. Well, it says 40 people are eating egg rolls, so the 40 must go here, and we're looking for the total number of guests in the restaurant. Well, how did I get from 80 to 40? I divided by 2. If I do the same thing on the bottom, it turns out there are 50 people in the restaurant. All right, and then the last problem on this page, on this side before we stop and do the second half of this study guide, says Donovan went out to dinner with his friends and had great service. He wanted to leave a 20% tip on his $65 bill. How much money will he leave as a tip? I'm going to do this in 2 different ways so you can see that there's options here. The first way is to set up that proportion. So we're going to, again, make our little structure. We know that we're trying to leave 20% tip, and we want to know how much money he's going to leave as a tip. So 20% is what we're looking for. And it says this was his total bill, and we want to leave a part of that as his tip. So 65 goes down here. We have simplified 20 hundredths a million times, but just in case you don't remember, we're going to divide by 20, and we get 1/5. So I'm going to rewrite this as something over 65 equals 1 over 5. Now, I know because 65 ends with a 5, that 5 is going to be a factor. So something times 5 definitely gets me 65. If I'm not sure what it is, I can divide. So 5 goes into 6 once, and 5 goes into 15 3 times. So we know that this was times 13, and 1 times 13 is 13. So he left a $13 tip. Okay? Now, if you didn't want to do it that way, we can also use decimals. We talked about how we could change 20% into a decimal by moving the decimal 2 places. So this is the same thing as this. Now, it's asking what 20% of 65 is. Of in math means multiply. So we could take our $65 bill and multiply it by this. Now, I'm going to put a little 0 placeholder here so that we remember that the time we go down, we put a 0 before we start to multiply. Don't forget that you have 2 decimal places after a decimal, so that will equal this, and you're still going to get that $13 tip. All right, guys, that completes the first side of the Unit 2 End of Unit Study Guide. Stay tuned for the second video, which will have the answer key to the back.